The word stoichiometry comes from the Greek words stoichio, which means element, and metro, which means to measure. So we use stoichiometry to measure the elements, to use what we know about the quantity of one species in a chemical equation to calculate the quantities of other reactants and products. Let's try putting stoichiometry into practice with an example from ancient Greece. In The History of the Peloponnesian War, Thucydides describes the Spartan siege of the city of Platea, which they eventually try to burn down by lighting a large pile of wood, tar, and sulfur outside the city wall. The fire nearly proved fatal to the Plataeans. A great part of the town became entirely inaccessible, and had a wind blown upon it in accordance with the hopes of the enemy, nothing could have saved them. As it was, the fire was put out by heavy rain and thunder, and the danger averted. So how did the fire make the town inaccessible? Was it the heat, the smoke, or something else entirely? This short passage is sometimes cited as one of the earliest recorded uses of chemical warfare. To find out why, let's see what happens when we burn sulfur in a fire that size. In the first step, sulfur is burned to produce sulfur dioxide. In the second step, sulfur dioxide is burned again to produce sulfur trioxide. When sulfur trioxide comes into contact with water, they react to form sulfuric acid. That last step occurs wherever sulfur trioxide comes into contact with water, and that includes on the eyes, in the nose, in the mouth, and lungs of the Plataeans inside the city. So how much damage could be caused by just some sulfur thrown on a fire? It doesn't say how much was burned, so let's just guess it was 100 kilograms and see what that can produce. The first thing we'll need to do is to determine the overall balanced chemical equation. That's 2 sulfur plus 3 oxygen plus 2 water are converted into 2 sulfuric acid molecules. The numbers in front of each one of these species are our stoichiometric values. We can use these to determine the ratio between the reactants and the products. We can't calculate the amount of sulfuric acid from the mass of sulfur, so we'll need to determine the moles of sulfur in 100 kilograms of sulfur. Next, we'll use the stoichiometric values to determine the ratio that will tell us how many moles of sulfuric acid we can produce from this many moles of sulfur. Finally, we convert the moles of sulfuric acid back into the mass of sulfuric acid using its molecular mass. And so we see from 100 kilograms of sulfur, we can produce 306 kilograms of sulfuric acid. The concentration of sulfuric acid in a modern lead-acid car battery is around 5.2 molar. That's 5.2 moles of sulfuric acid per liter of water. That means that the acid generated by burning 100 kilograms of sulfur at the Platean city wall would have produced as much as 600 liters of battery acid, all of it inside the eyes and the lungs of the people of the city. So whether or not the Spartans succeeded to burn down the city, sulfur trioxide in the smoke would certainly have been an effective chemical weapon. Today, we would classify that as a choking agent because it damages the lungs and mucous membranes. We'll hear more about choking agents on the modern battlefield in our next video.